Hello everyone, welcome to Z Talk. This session we're gonna continue on automation via Terraform on AWS. We're gonna talk about two important concepts. The first one will be autoscaling. And in the demo, I will show you how do we automate the process of enabling or configuring autoscaling on AWS EC2 instance. And then I'm gonna move to the second important concept, load balancing. I'm sure we're dealing with load balancing like every day in our production operations. The stuff covered in this session is kind of a little bit more than my previous ones, so stay tuned. All right. Let's start with autoscaling, which I guess I don't need much introduction. Everyone should be at least heard of these concepts, right? So autoscaling basically ensures that the instances are sufficient to run your application. It's one of the most important features provided by cloud technology, and I think it's also a fundamental difference between the Iron Age and Cloud Age. I mean, the move from unreliable software, which depends on the hardware to be reliable, to software that runs reliably on unreliable hardware, right? With this feature of autoscaling, for example, we are free to increase or decrease the number of servers or compute resources that depends on the load on my application to increase efficiency and avoid the waste on my resources. However, autoscaling does not come out of box. To make, for example, an EC2 instance autoscalable, we have to define something ahead of time on AWS. That's direct me to the next slide. Component of autoscaling. So here's the list of components for autoscaling. The first one is the group, which is mandatory. Group contains a collection of, I'll still use EC2 instance as example. Group contains a collection of EC2 instance with similar characteristics for scaling and or management purposes. For example, the web server with Nginx on it for my application. That could be a group, as I have the requirement for duplicating the web server to handle the load on my application. And you can just mix web server and application server together for autoscaling purpose, as the configuration system requirements are completely different, right? Autoscaling group keeps checking the status of the EC2 instance via a health check. If any instance becomes unhealthy, the group terminates that unhealthy one and launches another one to replace it. That's basically autoscaling. The second component is called launch configuration. It's a template for launching EC2 instance. It's pretty much like how we configure to spin up the EC2 instance manually. In that template, we need to specify the MIs, instance type, key pairs, security groups, and etc. Right? So the next component of autoscaling is scaling plan. Apparently, it defines when and how to scale. There are different types of scaling plans, like for example, maintaining the current instance level at all time. We can configure and maintain certain number of running instances at all time in a autoscaling group. Like the scenario I just mentioned, if health check identifies the health of a VM is unhealthy, this plan will automatically kicks in, kill that VM, and spin up another one to replace it. The goal is to ensure the total number of instances keeps as what we defined in the template, right? Another plan could be manual scaling, where you just specify the changes in minimum or max or desired capacity of the autoscaling group, and the group maintains the number of instances with the updated capacity. Users can also do something like tells the group to perform the scaling action based on a specific time, which is called skill-based scaling. It's quite common on e-com business. For example, let's say normally customers start shopping after work, like 7 p.m. every day. So we can define to scale out or instance at 7, and also like normally, let's say after 12 p.m. The customers will go to sleep, right? So at that time, like 12 p.m. we're gonna kick off that schedule-based auto-scaling to scale in to basically reduce the number of instances, like something like that. Last but not least, there's another type of scaling plan, which is the most advanced scaling plan, demand-based scaling. Basically, resources scales by using a scaling policy. All right. Cool. Let's jump to the demo. So in the demo, I'm gonna show you how do we configure auto scaling on EC2 instance to make it auto scalable. All right. Okay, I'm on my Visual Studio Code. For this demo, I'm still gonna use a couple of configurations that I defined over the previous sessions. So if you have been watching these series of Terraform, you should be familiar with them, like providers.tf, variables.tf. Basically, that's where I define the generic information like my AWS account info, my access key, private key, my default region, all those generic variables, right? And for this session, we're going to focus on this new configuration that I called autoscaling.tf. Here you can see already define the framework, what resources we need to define for enable autoscaling. And the first three resources are pretty much you should be familiar with, because I've been using them in my previous sessions, like the two data resource. Basically, the first one lists out all the availability zones based on the region I choose in the variables that TF, and the second data resource there was a filter inside of these resource. Basically, it just lists out the Ubuntu AMIs, right here. So the next resource is AWS key pairs. Apparently, it's just link up the public key, which I define in the variables.tf. All right. So let's continue the rest of the config for autoscaling. The first one is the easiest one. So we need to define a autoscaling launch configuration. Basically, I'm still gonna use the official documentation in the Terraform registry as reference. The first one, it's all we need to do is here it's this AWS launch configuration provides a resource to create a new launch configuration used for autoscaling groups, right? So if you can see inside of this resource, we just need to define the AMI, the image ID we're going to use for this instance, and the instance type, right? So I will already define the resource here, and I give the variable name custom -launch -config, and I use the data resource I defined above. So basically, I just called the Ubuntu ID here. And the instance type, I just used the minimal one, t2.macro, and the key name, so is this resource I defined above to grab the public key. All right, and then let's move to the next resource definition, autoscaling group. Okay, so let me jump back to the registry and for autoscaling group. So basically, this resource provides an autoscaling group resource. And here is the example. Basically, we need bunch of arguments inside resource like max size, minimum size, and health check criteria, and VPC zone identifier. So basically, for VPC zone identifier, we just need to put in the subnet ID, right? So in launch configuration, basically we already defined the launch configuration resource just now, right? We just need to refer to that. Okay, let's jump to my Visual Studio Code, and let's finish that part. Autoscaling group, and here let's start with I give the name custom group autoscaling, and for the APC zone identifier, I just grab from AWS portal. So go to my default region, US West 1, right? So for this demo, I'm going to use the default VPC and subnet. So click VPC, and here's the default one, and then click subnet, and you can see it shows the subnet ID. So I just grab this ID and put it here, AFA, right? And then the launch configuration is what I defined just now right here. So, and move to the next argument, min size and max size, and health check. Let's go back to the registry and take a look what these arguments for. Go back, go down. And here you can see these two arguments are required. Basically, it defines the maximum and minimum size of the autoscaling group. All right, and for health check, I used here, it's an optional argument. Basically, it just this health check grace period is the time after instance comes into the service before checking health, right? So the default value is 300 seconds. I will make, for this demo, I'll make it faster. I will give it 100 seconds, all right? And the health check type, so there are two options, EC2 or ELB. I just use the default EC2, all right? And force delete, this one is also optional. Basically, this argument allows deleting the autoscaling group without waiting for all instances in the pool to terminate. I will make it true. And for tag argument, and here tag, let me see, tag, right? The tag attribute accept exactly one tag declaration. So here is there are three argument, key value, and propagate at launch. all three arguments are required. So the last one, propagate at launch, enables propagation of the tag to Amazon EC2 instances launched via the ASG. All right, so I just followed the example and give a name, key's name and value is custom EC2 instance, and turn propagate at launch to true. All right, move to the next one. Define autoscaling configuration policy. All right, so these resource provides an autoscaling scaling policy resource, right? So you can see here is the example. There are a couple of arguments we need to define, like scaling adjustments and scaling adjustments. Let's see what these arguments for. Scaling adjustments, the number of instances by which to scale. Okay, so here it used 4 in the example, but for our case we're gonna scale up 1 at a time, so I'm gonna use 1. And adjustment type, there are 3 types here. Basically this argument determines the interpretation of this number. Adjustment type, adjustment type specifies whether the adjustment is an absolute number or a percentage of current capacity. So there are 3 options: change in capacity, exact capacity, and percentage change in capacity. I would just use the change in capacity. All right, so let's move to my Visual Studio Code again, and let's put in the resource. So I'm gonna use CPU matrix following resource of like in the CPU matrix in the CloudWatch. So I will give these policy a variable name custom CPU policy. All right. The autoscaling group name is basically the one it's referred to this resource as a defined here, right? Custom launch autoscaling. Custom launch, where is it? Custom launch group, where is the, here, custom autoscaling group and custom group autoscaling, the name. So it's referred to the autoscaling group, and adjustment type is changing capacity. Scaling adjustment equals to 1 because we're gonna do 1 at spin up EC2 instance 1 at a time, right? And cooldown equals to 300 seconds. So again, let's take a look what this cooldown for. Cooldown is another optional argument. Basically, it's the amount of time in seconds after a scaling activity completes and before the next scaling activity can start. So make our demo faster, I will give it a smaller number. Instead of 300 seconds, I will give 60 seconds. All right, and policy type is simple scaling. All right, move to the next one. Define CloudWatch monitoring. So we're gonna pick the CPU matrix in AWS CloudWatch and set up some threshold to trigger the action. All right. So here, let's take a look at these 4. Basically, I'm gonna use this resource, CloudWatch metric alarm, and give a name CPU alarm, right? So the alarm name is custom CPU alarm. Give it description is the alarm when CPU usage increases, and we set a threshold is 20%. If the value is more than 20%, and for 120 seconds, the average. So we're gonna trigger these alarm action, right? So the dimension basically the scope. I put the group autoscaling group inside of the dimension, and enable this action. And let's take a look at the example. Let me go back to the registry and go back here, and here shows some example. So for again, for here, this alarm action, and we gonna need to use these ARM format. So let me search for the explanation. So alarm actions is the list of actions to execute when this alarm transitions into an alarm state from any other state. Each action is specified as a ARM, Amazon resource name. So you can search for more if you're not familiar with ARM. Basically, it's the Amazon resource name. It has a specific syntax. I talked about that in my previous session, and you can just search for ARM, and you can read through in the AWS documentation. All right. So here, let me go back to my Visual Studio Code, and again, so I'm gonna use 20% as the threshold. So move to the next one, define auto descaling policy, and define descaling CloudWatch. Basically the same idea of autoscaling, right? I just need to create another two resource like these two above for defining descaling criteria. So, okay, let me just copy a descaling policy. So again, for cooldown, I will make it faster. So previous, I'm gonna use 60 instead of 300 seconds. I can make it 60 seconds. And scaling adjustment equals -1. Basically, let's take like scale. So this descaling gonna apply to all the instance. Basically, -1 it means all of the instance, right? And I'm still the rest is same. And define descaling CloudWatch. So same thing. I'm gonna create a threshold. Use the same metric, the CPU metric, and if the threshold is less or equal to 10%, the scale down action will happen. All right. Like here, is still use the same metric, CPU metric from the CloudWatch. All right. So that's pretty much it. Let's jump to the terminal and run Terraform to see how it looks. All right. Okay, I will do a Terraform plan. To run a pre-check, and looks good. It did not return any error. So let's do a Terraform apply. And type yes to approve. All right, looks good. Let's take a look. Let me jump to my AWS portal, and here let's go to the EC2 instance, and you can see there's a running instance, right? That's the one I'm talking about. Now for verifying if these autoscaling works or not, so I need to install some utility to generate load on these existing EC2 instance, so that we can verify when we got more load, the CPU is ramping up, and the usage is more than 20%, and let's see, let's verify if another instance will be scale out, right? So let's log in to this EC2 instance. So let me jump back to my Visual Studio Code, jump to my terminal and do a SSH, the IP, what's the IP here? -L, the name is Ubuntu, the username is Ubuntu, and the key is my key here. Okay, I'm in. So let me sudo root, and what I need to do a apt-get update, and I will need to install a utility called stress. Basically, that package is able to generate the load. So I will do a apt-get stress. All right, it's there. So let's run that. So stress. So I'll set some arguments, CPU2, and I will set up a timeout to 300 seconds. All right, so let's hit it. So let's give it a little bit time. So it start generating load on this instance. We should be able to see the CPU is ramping up. So let's go to monitoring and keep an eye on the refresh. Yeah, here you can see, if you click Autoscaling, you can see the launch configuration, which we define in the Terraform config, right? And go back to the instance, status check, monitoring. Here, so last 5 minutes, 1 minute. So let's be a little bit, it's gonna take a little bit time, because you see the health check grace period is 100 seconds. So you just need to be a little bit patient, and the period, and what we define is 120 seconds. Basically, that's 2 minutes. If the threshold is the value of CPU usage is more than 20% for 2 minutes, so the autoscaling should be kicked off. So let's see. I'll refresh. All right, see, it's because there's another instance is scaling up, right? Is in pending mode, because you can see here this was the original instance, right? So when you check the CPU usage, and you can see the usage has been more than 20% for over 2 minutes, and that's kick off the autoscaling, and that's why you see there's another instance is spinning up. All right, give it a little bit time. So we because in these VM, I set this stress utility to run for 300 seconds. So after that, the stress utility will stop generating load. So we should be we should see the CPU usage is ramping down. You see, it's successfully run complete in 300 seconds. So we are expected to see the usage is ramping down. So once the CPU usage is less than 10%, we are expected to see the descaling kicked off. So these instance should be shut it down and deleted, right? So let's give it a little bit more time and verify if it works as what we expected. Oh, there's another instance scaling up. I guess because previously you see here the usage was more than 20% for a while, so it start scaling up to 3. 3 will be the max. That's what I defined here. The policy here, minimum size is 1 and max size is 3. So now we should be expecting the descaling happening, right? So let's give it a little bit time. So now the usage ramping down to 0. So the descaling should be happening anytime soon. Let's give it a little bit more time. So see here, it's starting shutting down one instance at a time, right? So because you can see here, so the period is 1 minute. Let me keep refreshing. So the usage has been less than 10% because right now it's basically 0, right? So that's why the descaling policy kicked off, and you can see already one instance being terminated, right? So let's wait for another 2 minutes. The second instance will be terminated as well, right? So let's keep watching. Okay, here we go. So you can see the second instance are being shutting down. All right, I think these pretty much verified whatever we defined autoscaling worked as expected, right? So if you watch the metrics again, so refresh. So here we go. Because the value, the usage was less than 10%, the descaling kicked off, and previously because the usage was more than 20%, that's why the autoscaling kicked off, and there were 2 instances being spin up, and now we're back to the original 1 instance because the minimum size we configured was as 1, right? Minimum size is 1. Okay, so that's pretty much it. Let's move on to the next topic, load balancing. Okay, let's jump back to my slide to continue to talk about ELB, which is AWS Elastic Load Balancer. In the previous demo, we tested out autoscaling for EC2 instance. We saw when loads were ramping up, new nodes got spinning up. But consider a scenario where after new nodes up and running, right? What if the traffic is now routed to the new nodes? So whenever we scale out, we need to make sure the traffic will be routed to all nodes inside the cluster. That's basically where load balancer comes into the picture. Load balancer distributes the traffic across the targets that are attached to the load balancer. For ELB, user must specify one public subnet for at least 2 availability zones, and ELB monitors the health of the registered targets and routes traffic only to the healthy ones. What's more, ELB also supports SSL offloading, which allows ELB to bypass SSL. So basically, ELB decrypts the traffic and routes it to the targets. And because ELB and targets are hosted in the same VPC, the communication between them is actual plain text. And ELB takes care of, encryption or decryption when the traffics come in or goes out of the VPC, right? Next one, there are a couple of types of AWS ELB. So like classic load balancer, network load balancer, application load balancer. I won't talk about too much about classic load balancer because it's the old generation of load balancer. It's used for EC2 classic instance only, and it does not support host-based or path-based routing. The popular ones will be the next two, network load balancer and application load balancer. Basically, the difference is where the routing decisions are made. Like the routing decisions can be made in transport layer, which is TCP or UDP, that network load balancer, is able to handle millions of requests per second. Or the routing decisions can be made in the application layer, which is HTTP or HTTPS. That's application load balancer. Application load balancer supports cross-zone load balancing, right? And I will talk about a little bit about host-based load balancer balancing and path-based. Host-based is kind of old standard. Basically, host-based routing is what enables virtual servers on web servers. Basically, one IP, many hosts. That's really like kind of old standard. And path-based routing is getting increasingly common, particularly in the realm of scaling containers using ingress controller. But path-based routing requires visibilities into the URL portion of the HTTP request because that URL changes. I will jump to a browser to show you what I'm talking about. You see here, I'm on the home page of Yahoo, right? So it's www.yahoo.com, right? But when I jump to, for example, Yahoo Finance, if I click Yahoo Finance, and you can see the URI actually changed. You see here, it's not yahoo.com, it's finance.yahoo. What about something else? Let's try news. If I click news, and you can see the URI changes again. So that's basically what I'm talking about. For the path routing, we need to get visibility into this URI portion to make the routing rule, how we're gonna route the traffic. All right, cool. Let's jump back to my slide. That's pretty much load balancing. So we're gonna jump back to the demo again. For this demo, we're gonna configure load balancing AWS EC2 instance via Terraform. So before I jump to my demo, remember sum up my video and subscribe my channel if you haven't done so. All right, and feel free to leave comments or questions. I will reply as soon as I can. Okay, let's jump to the demo. Okay, I'm on my Visual Studio Code. For this session, for configuring load balancer, right? I'm gonna build the customization on top of the previous autoscaling session. So in the autoscaling session, I copied a couple of configuration files from my previous sessions, like variables.tf and provider.tf. Basically, I explained for this session, I'm gonna do the same thing. As you can see, I create a new folder called ELB and copy all those config files, the TF files, from the previous autoscaling folder to here. And I don't have to talk about again about the variables and provider.tf. That's basically generic info, right? As you remember. And for for configuring load balancing, as I mentioned in my slide, user must specify one public subnet for at least two availability zones. So I need to create a custom VPC, and that's why I refer these VPC to Terraform. As if you remember, I had a session previously to show you how we gonna build our own custom VPC. So if you don't remember, I attached the link to that session, that video, so you can go there, jump to there, and review what resources were used for configure the VPC.Terraform, right? Basically, it's the same thing. I just create my own VPC and create multiple public subnets in the VPC. That's pretty much it. And for this session for configuring load balancer, we're gonna focus on a new Terraform config file. I'll call it ELB.tf. Here I already listed out the framework. So the first resource we're gonna use is AWS ELB. We're gonna use that, define that resource to define our ELB configuration. And after that, we're gonna create two security groups. Basically, one security group for the ELB, and the other security group is for the instances, the EC2 instances. All right. And there's another one, that the autoscaling. That's basically what we just configured in the last demo for autoscaling. So I'm gonna use that as the framework, but I took off some of the resources inside this file because, for example, the descaling resources, I took it off, and also the CloudWatch matrix resources, I took it off because the purpose of this demo is for testing load balancer, so we don't need to consider that use case like descaling the VMs. All right. So beside that, I did a little bit change. Basically, I add two parameters inside the AWS launch configuration resource. As you can see here, I created a bash script. It's pretty simple bash script. Basically, I need to use these bash script to test or verify if the load balancer works. I will explain line by line shortly what these script for. All right. And besides these arguments, as I mentioned in the ELB, the Terraform, I'm gonna create two security groups, one for ELB and the other for instance. So once that security group are created, I'm gonna refer that security group right here in the AWS launch configuration. That's pretty much all I need to change in the autoscaling .tf. All right. Okay. Now let's jump back to the ELB.tf to define the AWS ELB configuration and create the security groups. All right. Cool. Okay, let's start with AWS ELB. Here is, I'm on the Terraform registry. This is the resource AWS ELB. And here is the example. So basically what we need to define the argument, the one required argument is availability zones and subnet, right? As you remember, we need at least two availability zones. In the example, it lists that three availability zones. And after the availability zones, we need to define the listeners. Basically, is the protocol and ports. After the listener, we're gonna define the health check. So here is like health is threshold equals 2 and then health is threshold equals 2. Basically, it will check the the node twice before it declare the node is healthy or unhealthy, right? So here, and it's cross zone load balancing. It turns to true as I mentioned. It supports cross zone load balancing, and connections draining. It turns to true. So for load balancing, connection draining is the popular concept. Basically, it enables the load balancer to complete in-flight resource requests made to the instance that are deregistering or unhealthy. That's basically what connection draining for. All right, and let's use this template and jump back to my Visual Studio Code. And here you are. So I give the variable name custom ELB, and for the subnets, basically that's what I defined in the VPC.tf. I created two public subnets. Here we go. Custom VPC public 1 and public 2. I include both in the ELB subnets. All right, and after that is the security group. That's basically what I defined right below. As remember, I'm gonna create two security groups, one for load balancer and the other is for the EC2 instances, right? So this one is for the load balancer ELB. So I give the variable name custom -ELB security group, right? So that's where I called it custom ELB security group ID, right? So for listeners, again, so we're gonna use HTTP, so which is port 80, right? So that's basically the listener I defined. After the listener, I'm gonna define health check. Basically, it's another required argument. Is the number of checks before the instance it declare healthy or unhealthy. I use 2, so basically, it's gonna check twice before it declare is healthy or unhealthy. And then I enable both cross-node load balancing and connection drain, and set the connection draining timeout is 400 seconds. All right, and down below is the security group. I had again, so I had sessions previously to discuss step by step how we're gonna use this security group resource. So I won't talk in detail. It's pretty straightforward. Basically, we just need to correlate the VPC we create again. So that's the information, that's the VPC I create in the VPC.tf, the first one, custom VPC, right? That's where I call the custom VPC here, and after define the VPC ID, and the next two section is ingress and egress. So for ingress, I need in the ELB configuration, the listener is 80. So in the ingress, I need to open port 80, right? That's basically what I did right here. That's pretty much it. And the next security group is for the EC2 instances. Same thing. We're gonna refer to the VPC that I created in the VPC.df and define ingress and egress. For ingress, because I need to get access to the these EC2 instance. That's why I just enable port from 22 to 80. So that's just for testing purpose, right? So that I can SSH to the EC2 instance. And the security group is the one I created. Custom ELB load balancer security group. that's included for the instance. All right. So because those EC2 instance will be attached to the load balancer. That's why I add the load balancer ELB security groups here. All right, that's pretty much it. The last step, the autoscaling. So as I mentioned, I add a argument, user data argument, basically attached a shell script so that once it's deployed, and we can use this shell script to verify if the load balancing works as expected or not, right? And beside that, I need to add another argument to include the security group. So here I will do security group, and I will include that custom instance security group here, because these resources for launch configuration basically is for the EC2 instance, right? So that's pretty much it. Let's apply and see if everything passed the pre-check by issuing a Terraform plan. Cool. Let me jump to my Visual Studio Code, my terminal, and just issue Terraform plan. All right, looks good, and you can see it did not throw errors, so we are good to go. So I will issue Terraform apply, and let it deploy to AWS. Terraform apply. And type yes to approve. Okay, the apply was successful. Let's log on AWS portal and verify the load balancer configuration. All right. So firstly, let's click EC2 instance, and you can see there are 2 running instances, right? And if you click each one of them, you can see the availability zone is US was 1C and 1B. That's basically what we defined in our config. And if you see the private IP, that's basically what we define in the VPC. If you can see the public, for these subnet, the CIDR block is 172.25.2.0, right? So back here, and I include these 2 public subnets. So the CIDR block 1 instance will be 172.25.2 something, and the other will be 172.25.3 something, right? Go back to here. So the first instance is .3.59, and the second instance is .2.52, right? So if you scroll down and click load balancer, and you can see this is the load balancer I defined in the ELB.tf, right? Custom ELB, right? And if you click instance, you can see the 2 running EC2 instance were attached to these ELB, right? So back to the description tag, and you can, there is the DNS name. So now let's jump back to the Visual Studio Code. In the autoscaling, the launch configuration resource, as you remember, I added the user data argument to include a shell script. Basically, this script is for verification if the load balancing works, right? So as you can see, it's pretty simple. So I installed Nginx on the EC2 instance, And next, I will do some parsing and show the IP. So basically, IP config list out. If you're familiar with shell command, basically IF config returns the IP address and grab using a regular expression. You're gonna grab the line with these keywords, inet address 172, and then I will do some manipulation to print out the IP and do a cut. Basically, cut command is used for return a substring. Let me show you step by step so you will understand more. So let me just copy these commands here, right? And back to my terminal, what I can do, I'm gonna SSH to one of the instance and run these command manually so you will see what is showing, right? So this is just for the ones who are not familiar with shell script. If you're good with shell script, it's pretty straightforward, simple script. Okay, so let me log into one of the EC2 instance. I will do an SSH. I will grab the public IP. So go back to the EC2 instance. And grab the public IP for SSH. Here we go. And SSH, the username is Ubuntu and the private key is here. Okay, now I log in and I will sudo to root, and I will run these commands to show you what it returns. So here you go. I'm gonna copy these commands. Right. Okay, and here we go. So basically it returns the IP address, and if I break it off, so the first one, the IP config, it returns the IP. So basically the next grab, I'm going to use regular expression to grab this line to filter out the other lines that I don't need, right? So if you can see, if I run these sections of the command, I will get this line. That's exactly what I need, right? And then I need to do some manipulation to use AWK command to got this section, right? So here, sorry, it's here. It returns this section, and last but not least, this cut command basically returns a substring of these strings. So this section, it use colon as a delimiter. So I will use field 2, which is this section. Basically, it parses out the IP address, right? So that's basically it, and then you're gonna do an echo and show it on the Nginx web browser. That's why we can just hit that DNS name to see the IP. So every time, if the load balancer works, every time I refresh, the load will be distributed to both EC2 instances instead of one, right? So let's test it out. Go back to the portal and let's go back to the load balancer and grab the DNS name. So here, the DNS name is this guy, and let's test it out here. Just hit it, And you can see, hello team, this is my IP. This is .3, so which is .3, which is instance, which instance is .3? I think the first instance, as I remember correctly. Here is .3, right? Let's do that again to refresh. You see here the load balancing happens. So now these requests was routed to the other EC2 instance, which is .2, right? .2. Let's refresh another couple of times to see. You see here, .3, .2, .3, .2. That's basically load balancer. We can verify load balancer worked as expected. The load was distributed by load balancer across 2 EC2 instances. All right. Cool. That's basically what I want to share for this session. I know it's a little bit long, longer than the previous sessions because I combined 2 important sessions together because they're related, right? So take your time, review this video, and feel free to leave comments or questions. Go back to my slide. All right, that's pretty much it. Thank you for watching, and see you next time.
All right, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.